Biotechnicans, this is Pallavi Poojar from Biotecnika. As already we have started the question paper series for NEET 2022, which already we have attempted. Alright, so I am going to consider the remaining part of chemistry subject, and previously one of our faculty has cleared your all doubts. I am going to consider the remaining part of chemistry. So today just I am going to explain you in detail. Alright. So shall we begin it, students? So I know that definitely you are going to join me faster and faster. So our first question will be based on the inorganic chemistry. So where they have correctly asked regarding the incorrect statement. So they have given 4 options where the incorrect statement you have to consider. So the 4 options, as you can see, ionization enthalpy of alkali metals decreases from top to bottom in the group, and option B where lithium is the strongest reducing agent among the alkali metals, and option C where alkali metals react with water to form their hydroxide, and the option D where the oxidation number of potassium in KO2 in +4. So just by looking at the question, so how you can approach? So what you have to do, first thing, it is mainly with respect to inorganic part, right? So inorganic part is a bit difficult to remember, you do think, but it is not. It is completely bit theoretical and some kind of numericals you have. It is in between organic and physical chemistry. So now coming to this question where they are asking you regarding the ionization enthalpy correlation and the oxidation state, okay, and apart from that the reducing agent. So overall the periodic table, whatever you have in chemistry, if you are thoroughly knowing it, then definitely you will answer it quickly within a second. So what they have given, the 4 options. So first option is with respect to its ionization enthalpy. So right, so they have given with respect to ionization enthalpy of alkali metal. So we know that in general, whenever you have the periodic table, the ionization enthalpy will be decreasing. Right, so down the group it always decreases, right? So with respect to what, why it has to be decreased? Because the nuclear, the interaction between the nucleus and the valence electrons will be lesser, right? Because the inner electrons, whatever they are there, so it is going to just shield your valence electron. That's why the interaction between the nucleus and valence electrons will be decreasing. That's why the ionization enthalpy will be decreasing down the group. Coming to your second statement, they have given the lithium is the strongest reducing agent among the alkali metals. Yes, obviously, so the lithium is strongest reducing agent among the alkali metals. And the fourth option they have given that alkali metals react with water to form their hydroxides. So in general, we know that overall alkali metals, if you consider lithium, sodium, and also where you can consider lithium, so it is treated with water molecule, and you will be getting your hydroxide. Okay, so definitely it is going to give me hydroxide. So just where the alkali metals are treated with water to form their hydroxide. Yes, this statement is also possible, means it is correct. Now coming to your fourth option, as you can say, it is oxidation number of potassium in KO2 is +4. Right, so here they are correlating with respect to potassium and oxidation, the oxidation state of potassium. So overall what you can see, the potassium, so KO2 is peroxide, right? So KO2 is peroxide, so that what you can see, the KO2 when you consider, so here it will be +1 charge and O2 minus you have, so it is anion. So overall the charge, the oxidation state, whatever you can see, it will be +1, not +4, right? So most of the alkali metals, they will show only +1 oxidation state. That's why what is your answer? That is incorrect statement is option D, right? So if you look at the answer here, you can see that answer D is correct for this question. Okay, now coming to your next question, where the organic chemistry part you have, they have given one reactant and series of reagents they have given. So no need of worrying. So what you have to do, you have your cyanobenzene, right? So cyanobenzene you have, and first reagent what they have given reducing agent. So just I am going to write it here, reducing agent. Okay, so just it is reducing agent. So which reducing agent they have given? They have given lithium aluminum hydride. So lithium aluminum hydride you have, and further you are going to treat with NaNO2 HCl, and at last you have water molecule. So 4 options whatever they have given, just you can consider that in the first option you have chlorine, and in the second option you have hydroxyl group, and in your third group you have, third option you have amide functional group, and fourth option where you have your diazonium salt, right? So we know that whenever NaNO2 and HCl is being given, it will be always giving me diazonium salt, right? So it is giving me diazonium salt just by looking at the NaNO2 and HCl, where instantly you are going to form HNO2. So just I am going to consider that first. So NaNO2 plus HCl, if you have, it is giving me HNO2. Okay, so this HNO2 further where the oxygen will be, the hydrogen whatever you have, so it will be further kicked out, and you are going to consider, after the elimination of water molecule, you are going to consider the NO plus electrophile, so that will be attacked by your nitrogen lone pair, which is already present in the corresponding reagent, with respect to reactant. Now coming to your reaction method, so just let us start one by one. So what they have given, firstly they have given your reducing agent. So what it will do, it will just convert your cyanide group into amine. So this functional group will be converted into amine in the presence of your lithium aluminum hydride. So you have lithium aluminum hydride, and just I am going to show you the product what you will get here. So you will get here CH2 NH2. So this is what amine you have got. So next step what they have given, they have given NaNO2 in HCl. So NaNO2 in HCl, so it will generate instantly HNO2. Okay, so it will generate instantly HNO2, and from this HNO2 you are going to get your electrophilic center, that is NO plus. Okay, so NO plus you are going to get, and that will be attacked by your nitrogen which is already present in your reactant part. So what you will get here, you will get your C6H5 CH2 and then nitrogen with 2 protons, where it will be carrying positive charge because here further it has attached to NO, right? So this is what you have got after treatment with NaNO2 in HCl. So just let us consider with respect to its remaining half of the reaction. So here what you have to do further you have your ring, and then what you have to consider with respect to its cleavage. So now we know that in any organic molecule, when it is carrying positive charge over it, so it will try to satisfy its valency. So nitrogen similarly, it will be try to satisfying its valency. So one of the proton will be going out. So just let me write it down here. H plus has gone out, and you have your C6H5 ring and CH2, where here I am going to write, and here you have your nitrogen, 1 proton, along with that it has NO. Right. So now the nitrogen valence is satisfied, but the thing that still it is carrying 1 more proton on it. Right. So what you want your final product. So you have to simplify the answer just by shifting the bond. So now further what you can do, you can kick proton, or else you can transfer that proton to your oxygen center. So how you can get, so this will be shifted here, and here oxygen will be carrying negative charge, right? So it will be like how C6H5 ring, you have CH2, and further what you have your further reactant part like this. So just I am going to show you here only. So just I am going to erase it. All right. So just what you have here, the thing is, so your ring you have, and carbon which has attached, like it will be your CH2. Okay, and further what you have your NH, and further you have your oxygen. So here your nitrogen along with oxygen, so it was having double bond. So this proton you are kicking out, so it will be shifting and it will be creating oxygen with negative charge. So further what you are going to get overall, so further you are going to get, just I am going to show you here, that nitrogen with double bond here, double bond, and oxygen with positive charge, 1 proton. So now OH you have, so whenever you have OH in the ring, so you can remove it easily just by protonation as water molecule. So just protonate this, oxygen will be positively charged. All right, so after that what you will get your corresponding, so just I'm going to erase this here. Okay, so just I am going to erase this, and further you are going to get your ring where CH2 you have and nitrogen again triple bond N. So further what you are getting your diazotized product, so where it will be carrying Cl minus also. So here what you have converted this C triple bond N into CH2 NH2. Okay, so it is converted into C6H5 CH2 NH2. Okay, so you are getting, and further you are following. Now, so you have got your diazotized product. So in all the options what they have given one of your diazotized product also, right? So it has not stopped here. Further they have given water molecule. So they have given water molecule, then overall you are going to break the bond. So just you are going to break the bond in order to get your final product. So if you break the bond, so what you will get here? So we know that N2 whenever you have in a molecule, it will be going out as N2 gas. So just kick it out as N2 gas, and you will be getting your C6H5, then CH2 you have, right? So this CH2 will be further attacked by OH. Okay, so that OH has come from your water molecule. So water molecule where you can split it as H plus and OH minus, right? So this OH minus will be attacking your electron deficient carbon. So after the removal of your N2 gas, the carbon will be electron deficient. That's why OH minus will be satisfying it. Okay, so what you have got overall, you have got alcoholic product. So in which option you have your alcoholic product? You have in your option B. So the correct option B is, the correct option for this question will be option B. Okay, now coming to your next question where it is based on inorganic part only. So in case of inorganic part, they are correlating with respect to the 3D orbitals, 4D and 5D orbitals. So overall, so you can correlate with respect to their shapes also. So the correct statement or incorrect statement they are asking. So what they are asking here, incorrect statement from the following. So yeah, what options they have given? In an atom, all the 5 3D orbitals are equal in energy in free state, and the option B where the shapes of dxy, dyz and dzx orbitals are similar to each other, and dx square, y square and dz square are similar to each other. And nextly, the option C where they have given all the 5D orbitals are different in size when compared to the respective 4D orbitals, and option D where all the 4D orbitals have shapes similar to respective 3D orbitals. So these are the options they have given. So now what you can consider with respect to the incorrect statement. So which statement whatever they have given is incorrect, you have to choose. So now with respect to this, just if you correlate here with respect to their energy, they have given the shapes of the d orbitals also and the size of the d orbitals also. So the option A whatever they have given, that is with respect to 3D orbitals. So they are telling that they are equal in energy. So equal in energy in the sense they are degenerate, right? So they are degenerate. So they are degenerate. So your option A is correct. So it is not incorrect. Now coming to your second option where they are considering with respect to dxy, dyz and dzx orbitals are similar to each other, and dx square, dx square, y square and dz square are similar to each other. So they are considering with respect to dx square, y square and dz square. So whenever you consider their picture, their orbital picture, so just it will be looking like this. So you have your y, x here. So how you will show? You will show the orbitals like this, right? So this is for xy, and here also xy. Okay, so this is what the case you have. So this is with respect to dx square, y square, but when you have with respect to your dz square, this is bit different. So where you can show your dz square orbital here. So this is what you have, and the orbital you can show here. Okay, so this is what your dz square. That's why what we can say, both are different from each other, right? So the option B will be your incorrect statement. Now coming to your option C and option D, both are correct because you are going to apply the principal quantum number and the azimuthal quantum number with respect to the shapes and size of the d orbitals. All right, so in this option what you can choose option B is correct here. Okay, now coming to your next question is with respect to IUPAC. So IUPAC is one of the simple topic, whatever you can answer quickly. So when you consider the IUPAC overall, so first they have given your bromine, alcohol, chlorine. Okay, so first whenever they give any IUPAC structure in order to give, so there you have to correlate with respect to the functional group present. So what functional groups they have given? OH, BrCl. So what priority order you will pick with respect to functional group also matters. So in all the three functional groups, OH you have, right? So you have OH here. So this OH has to be given first priority. Apart from that, you have bromine, chlorine. Now, if OH was present at the terminal carbon, I was just considering it as first. Okay, so it must get lowest number. That's why I will start from the first carbon. But you can see it is present in between of the carbon chain. Now there will be confusion whether I can start from this carbon or else this carbon, right? So you have to start the numbering in such a way that the OH group should get lowest number. If I start from this carbon, okay, 1 2 3 4 5 6 you have got. Okay, so if you are starting from bromine side, so where the carbon is being attached to bromine, if you are starting from there, you are getting 3. If you start from your next method, where you are going to start from here, 1 2, again this is 3, this is 4 5 6. Okay, so you are getting 6 overall. But the thing that when you compare with respect to 4 and 3, so these are what you have, 4 and 3 locants, right? So 4 and 3, where 3 is the lowest number. So if you start from numbering from the bromine attached, which is carbon here, so the hydroxyl group is getting lowest 3 number. So in all the options, you have to correlate that in which option the hydroxyl group is being shown in its third priority group. So when you consider with respect to their options, you can see option 2 and option 4. I mean 2 and 4 or B and D, whatever we can say, those are not correct. So where they have shown with respect to 4 priority order. So now 2 and 4 are erased. Now remaining all what you have left, you have left either 1 or 3. So with respect to 1 and 3, if you compare here, so the 1 bromo 4 methyl 5 chloro hexane 3-ol they have given, and option 3 where they have given 1 bromo 5 chloro 4 methyl hexane 3-ol. So here you have to consider with respect to chlorine and bromine also. So whenever you are going to consider the IUPAC, you have to check with respect to their alphabetical order also. So alphabetically, bromo is coming first, so consider bromo and then chloro. So the priority order will be given first bromine, then chlorine. Okay, so now bromine you are going to consider, that's why your option C will be correct here. So whatever I have mentioned here, it is option C is correct with respect to your given structure. Okay, so if you consider here, option 3 is already given. Now coming to your next question is with respect to gadolinium. So gadolinium has low value of third ionization enthalpy. So here they are correlating with respect to your third ionization enthalpy. So gadolinium you have, so it has either, I mean its third ionization enthalpy is low. So whenever we consider the ionization enthalpy, okay, ionization enthalpy, so you have to consider with respect to their electrons, I mean valence electrons. So whenever in case of d block elements also we have that one case, whenever any orbital we consider, that is d orbital or f orbital or s p orbital, if it is half filled or else completely filled, if it is completely stable, right? So it is completely stable. So same way when you consider the gadolinium, so overall in F block you are going to consider, so its configuration you can write it like xenon, and where 4f7 then 5d1 you can write, right, s2. So here, if you are going to remove these electrons, I mean, if you are going to remove the d orbital electron, and it will be attaining its F7 configuration. So F7 where F will be fulfilling with 14 electrons, but if we reduce its half, then it will be 7, right? So it will be what? It will be more stable. So for that case, if you consider with respect to the given options, that is high electronegativity, small size, high basic character, the high exchange enthalpy. So where they have mentioned the high exchange enthalpy, that will be your proper answer for this question. Okay, so your option D is correct for this question. So this is what already mentioned here, that is option D is correct for this question. Now coming to your next question, where directly they have given the IUPAC name for the atomic number 119. So in case of atomic number, whenever they give, you are going to consider its prefix, suffixes and all, right? So now with respect to this question, you have your answer, that is option C. So the direct question you have, so the option C, as you can see here, so this is what you have, ununanium. So 119 atomic number, how you can name it? It as ununanium. All right. Now coming to your next question, that is match list 1 with list 2, like match the following type of question. So they have given hydrides and their nature, and options also you can see overall. So here I have mentioned the options. So MgH2, germanium hydride, B2H6, that is boron, and HF is being given. So their nature is whether it is ionic, covalent, electron deficient, electron rich, electron precise. So that nature you have to find out. So if you want to find out, then what you can say? First, considering the magnesium hydride. So magnesium hydride, what type of compound it is? So what type of hydride it is? So mainly whenever we consider the alkali hydrides or alkali metal hydrides overall, so they are always ionic in nature. That's why what I can show here, that is magnesium hydride is ionic in nature. Okay. Now germanium hydride, if you consider germanium hydride, or else what we can say, germanium is coming under group 14, right? So all germanium hydride are always electron precise in nature. So in case of this, where germanium hydride will be electron precise in the sense what, they will be having sufficient electrons in order to form covalent bond. So that's why we call them electron precise hydride. So germanium hydride is electron precise in nature. Coming to your B2H6, we know that borons are reactive. Why? Because they are electron deficient in nature. Okay, they are electron deficient in nature. And HF is remaining. We know that the electronegativity difference is high and they are electron rich in nature. All right. If you consider with respect to these hydrides and nature, so what option you will choose here? So the option will be your C. So if you want to go back here, option C, you can see here. So option C, where A to 4, right? So A to 4 already I have marked, and then B to 1, right? So B to 1 you have, and next you have your C to 2. So C to 2, that is B2H6 is electron deficient. At last you have D is 3. So D is 3, what you have? It is electron rich in nature. All right. So this is what the case you have with respect to your hydrides and their nature. Coming to your next question, that is organic chemistry part, where the RMGX they have given, and they have given CO2 also. So here the direct question you have, the approach is clear. They have mentioned dry ether, and you have to find out your Y. So you have to find out your Y, and H3O plus is further is being given, that is acidic hydrolysis you are doing, and you will get your final carboxylic acid product. But the thing is, you have to know what is Y. So what is Y in between what you are getting, just to get your carboxylic acid from Grignard reagent. So now all the options you can see, that is RCOX plus, RCO2Mg, and RCOMgX, and R3COMgX. So if you consider here, so just I am going to consider the reaction RMgX you have, and you are going to treat with your C double bond O, C double bond O. All right. So here you are going to split the Grignard reagent as R minus MgX. So R minus is what? Electron rich. It will go and attack on your carbonyl carbon, that is electron deficient, right? So this is what C double bond O you have, right? So here after attacking, the oxygen will be grabbing electron density towards it, right? So here what you will get, this positive part will be attacked by oxygen. So you will get your carbon along with C double bond O, and here you have your alkyl group and oxygen with MgX, right? So MgX you have overall. So this is what the part you have got with respect to your Y. So what Y you have here? Option C. So option C, if you correlate the structure, it is R C O O M G X. So option C is correct for this question. Okay. Now coming to your next question, you have to again match the list 1 with list 2. So again, this is direct question. Okay. So direct question. So where you are going to consider with respect to the drug molecule and the drug class. So what type of drug class you have and the drug molecule. So here the option will be option D is correct for this question. Okay. So just I am going to show you here along with that. So option D you have here, right? So A is again matching to your 3. Okay, so that is 3. That is antacids are antacid, that is cimetidine is nothing but antacid, and B again it is for what? Fourth group, that is fourth, I mean drug class is antihistamine, and the drug molecule is your Zelda. So Zelda you have, and where C is your drug class and 2 is your drug molecule. So analgesic is morphine. At last, antimicrobials is your salvarsan. So this is what the match the following type of question with respect to drug class and drug molecule. Here you have to remember the drug class along with their examples. I mean the molecules whatever they give. And coming to your next question. So next question you have, which of the following statement is not correct about diborane? So they have given with respect to diborane structure. If you want to answer this question, first you have to know the diborane structure. So how exactly diborane looks? So diborane is like this. You have borane, right? So just I'm going to show you once again here. Okay, so you have boron, and boron is attached to hydrogen here. Again hydrogen, right? And again here you have your two hydrogens, right? So this is what the boron you have, right? So whenever you are considering with respect to diborane, so they have given 4 statements. The first statement is the 4 terminal hydrogen atoms and the 2 boron atoms lie in one plane. So these two hydrogens, and this boron, these all are lying in a single plane, they have told. Okay, so if you just consider its structure, so just let me show it in bit different way. That is, you have your different kind of bonding also in diborane, right? So now if you have boron here, okay, and you have your hydrogen, again you have hydrogen, so there is terminal hydrogen, so this is your next hydrogen, right? So you have here, so they have told that these two hydrogens and boron, so these all are like boron, hydrogen, I mean terminal hydrogen, all are lying in single plane. So they are lying in single plane, but this BHP, this H2 whatever you have, so this is in different plane. So it will be like how? It will be upper and lower. Okay, so upper and lower. So one BHP whatever you consider, this will be upper and this will be lower type. That's why your statement 1 is correct, right? So statement 1 is correct. And next statement they have given both the boron atoms are sp2 hybridized. So if you look at the structure clearly, there is no any sp2 hybridized boron hydrogen bond. So here it is sp3 hybridized. So this is sp3 hybridized. That's why your answer has to be option B here, option B. But just let me clear your different statements whatever they have given. So with respect to that, further what they have given with respect to 3-centered 2-electron bond, so they are telling that 2-centered 2-electron bond exists in case of diborane, right? So your option C what they have given, that is 3-centered 2-electron bond, right? So if you look at the structure clearly here, so just let me show here. So this is what your 3-centered 2-electron bond. So hydrogen which is showing means which is being shown as bridge type, right? So this is what your 3-centered 2-electron bond. Yes, their existence of your 3-centered 2-electron bond. Apart from that, their existence of 2-centered 2-electron bond. So 2-centered 2-electron bond is related to your terminal boron hydrogen bond. So this is what your 2-centered 2-electron bond. So what is your incorrect statement here? The incorrect statement is your option B. I mean what they have told, the boron atoms, I mean the both boron atoms are sp2 hybridized. No, they are sp3 hybridized. Okay, so the option B is correct for your this question. Now coming to your next question is related to your aliphatic amine and correspondingly whether it is forming the stable diazonium salts or no. So given below 2 statements, so two statements overall you consider, that is statement 1, the primary aliphatic amines react with HNO2 to give unstable diazonium salts, and the statement 2 where the primary aromatic amines react with HNO2 to form diazonium salts which are stable when above 300 Kelvin. So they have mentioned certain temperature with respect to diazonium salt formation. So here the options they have given, that is statement 1 is correct but statement 2 is incorrect, and option B where statement 1 is incorrect but statement 2 is correct. Okay, and option 3 where both statement 1 and statement 2 are correct, option B, option D lastly, it is both statement 1 and 2 are incorrect. So both are incorrect they have given. So what we have diazonium salt formation. So whenever we consider the diazonium salt formation, we consider for the aromatic hydrocarbon, right? So aromatic amine we consider. So in case of aromatic amine, when you consider, that is simple primary aromatic amine. So that is what the aniline you have. So whenever you treat this aromatic amine with corresponding HNO2, okay, so how you have generated it with NaNO2 in HCl, right? So just it will create NO plus, that is nitrosonium ion, that will be attacked by your nitrogen which is carrying lone pair, right? So correspondingly it is forming diazonium. So it will be forming diazonium here. So this diazonium salt formation, whatever you have, so it will be considered under 283 Kelvin or else 273 Kelvin. So 283 Kelvin temperature range. It's not above 300 Kelvin. It is in between 273 and 283 Kelvin temperature. So according to statement 2, they have given that the diazonium salt formation with respect to aromatic amines is more than 300 Kelvin. So the temperature they have increased. So your statement 2 will be obviously wrong. All right. So now we confirm with respect to statement 2 is incorrect. Now in all the options, in which option we have the incorrect statement with respect to statement 2. So in case of first option, you have that statement 1 is correct, statement 2 is incorrect, and at last in case of your statement 2, option B, you have statement 1 is incorrect but statement 2 is correct they have given, right? So now if you consider that overall, so statement 1, suppose we are correlating the stability of the formation of diazonium salt with the aliphatic amines. So primary aliphatic amines will be completely unstable compared to aromatic, right? So your option A will be correct for this question. Suppose you look at the option here, it is correct. All right. So this is what with respect to your aromatic amine and the aliphatic amine comparison. Now coming to your next question, where it is being given with respect to your coordination complex, the direct question where Ag water, H2O they have given, along with that AgCN they have given. So just you have to consider its IUPAC name. So in case of coordination complex, you have the IUPAC nomenclature, right? So now in case of these type of questions, what you have to do, that to in IUPAC name for the coordination complexes, the oxidation state of the metal is most necessary condition, because you are going to mention the oxidation state of the metal. In case of AgH2O twice and AgCN twice, so Ag is in its +1 oxidation state. So in all the given options where you have between 1 and 2, you have your +1 oxidation state, but +2 oxidation state you have in your option C and option D. So option C and option D both are erased. So these are erased. Now remaining 1 and 2. So in 1 and 2, if you consider here overall, okay, so just let me consider that overall. Okay, so in case of this, so with respect to water, you can give aqua as the answer, and CN you will be giving it as cyanido, right? So if you correlate with this, you will be getting answer as option B. Okay, so answer is option B. So oxidation state is same, but the thing they have considered that cyanide and water molecule first and last. So aqua should be first because alphabetical order you are considering, right? So here water is where it is mentioned as aqua. Okay, and cyanide as cyanido, right? So cyanide as cyanido you have, so your option B must be correct here. All right, now coming to your next question, you have with respect to Zelda's method. So Zelda's method, where nitrogen analysis is mainly done by using Zelda's method, right? So why we are using Zelda's method? So Zelda's method is mainly used for the analysis of nitrogen content in protein, right? So just you are going to consider any protein content and all, and you are going to consider its estimation, means how much proportion of the nitrogen is present in that. Now coming to the question, the Zelda's method for the estimation of nitrogen can be used to estimate the amount of nitrogen in which one of the following compounds. So 4 options they have given: aniline, and diazotized product they have given NO2, that is nitrobenzene, at last pyridine they have given. So one case we have with respect to your Zelda's method. So Zelda's method is not applicable for your nitrogen containing as NO2, azo, and pyridine. So in all the options, if you look clearly, option B, C, D, where you have diazo, nitrobenzene, and pyridine as answer, right? So you can erase your 2, 3, 4 options. So option A, that is aniline, will be correct here. Okay, so aniline will be correct for your question. All right, so just let us look at the answer. What you will get here, option A. Now coming to your next question. So this is regarding your electrolytes. Okay, flocculating power you are going to consider. So the question is like this: given below are two statements. So statement 1, statement 2 they have given. In the coagulation of negative sol, the flocculating power of 3 given ions is in the order Al3 plus, Ba2 plus, Na plus you have. So first they have considered with respect to your cation. So first you are going to consider with respect to your negative sol, the coagulation of negative sol, which is given in the ions for your Al3 plus, Ba2 plus, Na plus. Now your statement 2 is for the positive sol. In the coagulation of positive sol, the flocculating power of 3 given salts is in the order NaCl, Na2SO4 and Na3PO4. In the light of the above statements, just choose the most appropriate answer from the options given below. Again, you have to answer me with respect to the statement whether it is correct, incorrect, or no. So what you can apply here overall? So just you have to consider the flocculating power. So one thing we know that in case of electrolytes, you are going to apply the Hardy school's rule, right? So in according to that rule, what you have, the cation, whatever they have given with respect to your negatively charged colloid and positively charged colloid, whatever you have, so where you are going to consider overall the charge of cation and anion, right? So in case of statement 1, what they have given, the coagulation of negative sol, the flocculating power of 3 given ions is in the order, that is Al3 plus, Ba2 plus, Na plus 1. So Al3 plus, where the charge is more, 3 plus is charge is more, right, with respect to aluminum. Now if you consider with respect to barium, where 2 plus you have and Na plus they have given. So now with respect to this question, if you consider here, so this statement is correct. So this statement is correct. Now coming to your statement 2. So statement 2 they have given, in the coagulation of positive sol, the flocculating power of 3 given salts is in the order NaCl, Na2SO4, Na3PO4. In the light of the above statement, just choose the most appropriate answer from this. So what you have the reverse order. So it has to be Na3PO4, Na2SO4, NaCl. Then you could have choose that the statement 1 and 2 both are correct, but they have given the reverse order. Your statement 2 is incorrect here. Only your statement 1 is correct. All right, so this is what the answer you have. So in which option you can see that statement 1 is correct but statement 2 is incorrect? So in option A you can see, so statement 1 is correct but statement 2 is incorrect, right? So this is what the option for your question. Now coming to your next question, that is given below are two statements. So one is labeled as assertion and the other is labeled as reason. Okay, so assertion is ICl is more reactive than I2, and reason R is the ICl bond is weaker than II bond, that is I2 bond. So here they are considering with respect to iodine, okay, iodine and iodine chlorine bond. So they are considering I2 bond and ICl bond in the sense. So one molecule is what it is interhalogen compound. So there comes the concept of interhalogen. Okay, so we know that compared to normal, homodiatomic halogen molecules, the interhalogen compounds are more reactive. Why they are reactive? The bond, whatever you consider with respect to ICl, is we can break it easily. But when you consider the I2 molecule, that is homodiatomic molecule, the bond cleavage is very difficult, right? So what assertion they have given? ICl is more reactive than I2 they have given, and reason are they have given ICl bond is weaker than II bond. And in the light of the above statement, just choose the most appropriate answer from the options given below. So A, where the options they have given like A is correct but R is not correct. Both, option B where A is not correct but R is correct, and option C, where both A and R are correct, and R is the correct explanation of A, and 4, where both A and R are correct, but the R, whatever the reason they have given with respect to your A is not, the explanation is not correct, they have given like that. So here you have to consider your assertion along with the reason, whether it is mainly related with respect to your given assertion or no. So that you have to correlate and you have to pick the answer. So already I have explained that with respect to ICL and I2. So ICL is more reactive than I2 they have given, and reason they have given ICL bond is weaker than I2 bond. Yes, obviously. So what I have told that ICL bond breaking is more easier compared to your I2 bond. So I2 bond, whatever you are considering, that is between your two iodine molecule, iodine atom. But when you consider your ICL, so ICL is between your two different halogen atoms. All right. So that's why your answer should be what? Option C. Okay. So if you go back here, that is option C here. So this is what you have. Both A and R are correct, and R is the correct explanation of A. So both are relating with each other. So just by looking at the question, what you remember or what you think, that I2 they have given and ICL they have given. So assertion ICL is more reactive than I2, but reason ICL bond is weaker than I2 bond they have given. So reactivity and bond property, how they are correlating. So you have to think in that way. So if they are correlating with respect to reactivity, their existence of the reason that bond breaking or else bond formation. So bond breaking, they are mainly considered with respect to reactivity. That's why ICL, that is interhalogen compound, is more reactive compared to your iodine. Okay, so this is what the case you have with respect to your corresponding answer, this question. So this is what the final question I have solved, and the remaining questions I am going to solve in my next session. Until that, if you have any doubt, you can ask me, and you can join me at least in my next session. And all the best for your future, where definitely you are going to get your seat. And thank you. Bye bye.